learning about expressions that involve negative and fractional indices. All right, we'll have to simplify and evaluate expressions that have negative powers and fractional indices. First of all, let's look at a few numerical examples. What does it mean 5 to the power of negative 3? How can you evaluate and simplify it without a calculator? You need to understand what it means. A calculator can only do so much for you in an exam. So, to rewrite that with a positive power, you would have written as 1 over 5 to the power of 3. The negative power means that send it in the denominator or its reciprocal. Okay, we know that 5 to the power of 3 is 125, so the answer here is 1 over 125. The next example, the I would first of all get rid of the minus in the power by writing the fraction as its reciprocal. 1 over 1 over 4, that is to put it 1 over a quarter, is going to give us a 4. So I write this as to the power of plus 4. Notice I changed the minus sign in the index to put a plus sign because I am taking the reciprocal of the original fraction. So 1 over 1 over 4 will give us a 4, and the power is 4. So 4 to the power of 4 is 64, because 16 times 16 is 64. Sorry, no, that would be 4 to the power of 3, so actually it's 256. 64 times 64 is 256. Alright, so now we have a negative and a fraction for the index. So first of all, we can change the negative power to positive power if we write 1 over 81 inside the bracket. And then we can put the power of 1 quarter. Now, what does it mean to have a power of 1 quarter? That means we are actually finding the fourth root of this 4 is coming from here. Fourth root of 1 over 81. Now, I know what number 3 to the power of 4 will give me 81. So this is somehow related to 3. So the fourth root of 81 would have been 3, but because we have 1 over, so what we can say is 1 is fourth root is still 1. We are really taking the fourth root of 81 because 1 wouldn't have changed. So that's 1 over 3. Okay, so let me get rid of this. So have a go at the next example and then check your answer with me. To rewrite minus 8 with a positive power, I would have had to change it to 1 over minus 8 and then write power of a third. Power of a third means finding the third root. The third root of 1 over minus 8. Now, third root of 1, that is cube root of 1, is still 1. But the cube root of minus 8 is minus 2. So the answer is minus a half. Alright, have a go at the next question and then check your answer with me. If you're not sure, you can write this because because of the minus in the index, you can write this as 1 over 27 with a positive power of 4 over 3. Now, what does it mean to have a power of 4 over 3? You can split up 4 over 3. 4 over 3 means 4 times a third. Okay, so you can split up the power into its fraction, into its parts. So you could say, actually, I can find the third root of 27. So I'm going to write 1 over 27 with the index of a third, and then put a bracket around it and put it to the power of 4. Because when we multiply 4 by a third, we end up with this expression here, 4 over 3. So, third root of, inside the bracket, the third root of 1 is still 1. Third root of 27 is a 3. So that, once it's cube rooted, or we found the third root, we're going to raise it to the power of 4. So 1 over 3 needs to be raised to the power of 4. 3 to the power of 4 is 81. So the final answer is 1 over 81. Okay, I hope you found this helpful. Let's look at uh, some more questions. So every time you see 1 over some power, a fractional index, you rewrite it like so for yourself. Alright, 1 over m was the index. So we finding the mth root of a. Here you split up the fraction as nth root first and then raise it to the power of n. Okay, because we're writing n over m as 1 over m multiplied by n. And we can, when we have multiplication between powers, you can use a bracket. Alright, so a negative index means send it in a denominator or take its reciprocal. Alright, so if you had a to the power of minus 2/3, you could have written it as 1 over a to the power of 2/3. Right. So any base raised to 0, power of 0, is always 1. We call a here the base, and 0 is index or exponent. Another word for index is also exponent. You might want to add that to your vocabulary. So let's look at some examples. Here we are evaluating this expression here. We are saying that x to the power 3 in the denominator minus a minus 3, because of the division, that's where this minus sign comes from, and this negative sign belongs to 3. So that's why we end up with x to the power of positive 6, because we end up adding indices. Now here you have to add the indices when you multiply in the bases. So add 3 over 2 to half, you get a 2. Here you have to multiply the indices. 3 times 2 over 3 will leave us with a 2. Now cube root of 125. So you could take cube root of 125 and say 6 divided by 3. So we'll end up with 5x squared. Or you could rewrite it like so. Alright, split it up into its here we are distributing the power here, third root of 125, and multiply 6 by a third. You get x squared. Alright, so have a go at this last question and then compare your answer with me. Alright, you can split it up into two fractions and simplify each fraction separately. You end up with Alright, once you simplify the fraction, you end up with this expression here. You can rewrite the negative, put the indices in the denominator, bring them up, and write it as 2x to the power minus 3. But that's not absolutely essential. But it's good to understand how they are equivalent to each other. Alright, so just working out these, make sure you understand how to use fractional indices without a calculator, and learn some few examples of raising these numbers to the power of third and finding cube root of them. It's important that in A-level maths you're familiar with the answers here. Without a calculator, you should be able to answer all these questions. So we're finding the square root of 49 and then raising it to the power of 3. and so on. Okay, so in this next example, we've been told that y is 1/16 times x squared, and we've been asked to find the square root of y. That power of a half on y means that really we can we don't have to take the square root. Just multiply out the raises to the power of a half means that put a bracket around it and times powers by half. 1/16 to the power of a half is 1/4, and x squared raised to the power of a half will just simply give you x, because half and a 2 multiplied with each other are 1. So that's the final answer here. In this next example, it's the same y, uh, but this time we have to rewrite it as 4 times y to the power of minus 1. So we put a bracket around y, and we multiply it by 4 and raise it to the power of minus 1. The 4, notice, doesn't have a power of minus 1, because this index only belongs to y. If they wanted you to raise 4y to the power of minus 1, they would have told you to evaluate this expression. So that's not what we are doing. This 4 is outside the bracket that gets the power of minus 1. So leave the 4 alone as it is, and raising anything to the power of minus, the fraction will be reciprocated, so it will become 16, and x to the power of 2 will be x to the power of minus 2. So this is the numbers that you end up with, and then you multiply 4 and 16, and you get 64. So the final answer is 64 over x squared. You could have written this as 64 over x squared, but this is the same expression. Alright, so happy practicing, and I'll see you in the next video.